A metal from group 1 entitled X and an element from group 17 entitled Y react to form a compound. Which of the following claims is most valid about the compound? Okay, so then we have like A through D answer choice. Would it likely be a gas at room temperature? Would it have the formula X2Y? Is it soluble in water, or does it contain polar covalent bonds? Okay, so let's gather up some information that we know about this possible compound and then start chipping away at the answer choices. So they did mention that we have a element X, right? X and Y, they're just generic terms. They're not really, any elements on the periodic table. Okay, so we have X, and they did say that it's group 1. Okay, but they also told us that we had a specific element, and it did say that it was a metal. The metals in group 1 are called the alkali metals, right? Now, this was a big thing because generally in group 1, you also have one non-metal, which is hydrogen. So they're signaling out that this could be possibly hydrogen, that this is just all the other metals. Okay, so we definitely know that we have a metal. It's an alkali metal. And we're now dealing with Y. Y, which is, they're telling us group 17. Now, group 17 is the second to last group on the periodic table, right? Do we know what name that is? Yeah, those are your halogens. Halogens are, we'll say, group 17, but sometimes they might say it as 7A. They go by two different names, so just check out the last number in the group. If they're starting to give you like 13, 14, 15, we look at the last number. Okay. And generally, your halogens are going to be nonmetals. You're all the way on the right side of the periodic table, so that's a nonmetal. So we have a metal plus a nonmetal. What type of bond is a metal plus a nonmetal? You got it. It's an ionic bond. An ionic bond is, generally the consensus is metal plus a nonmetal. Now, are there exceptions? Sure, but when you have alkali metals from group 1 with halogens from group 17, you totally can say that that's ionic. They're way too different on the periodic table, different electronegativities, so it's ionic, which means that it wouldn't be covalent. So, letter D says that it has covalent bonds. Covalent bonds are between nonmetal plus a nonmetal. So, by definition, since we have that metal there, we know that it can't be covalent. So bye-bye, we are now down to 3 answer choices. Now this is kind of like properties, right? They're saying specifically, will it have the formula X2Y? Well, this goes back to when you learned how to make compounds with ionic compounds. We took those oxidation states. Group 1, the first group on the periodic table, always has a +1 charge. And the halogens, right, being 1 electron less than the noble gases, they would want to gain 1 electron, making them all -1 charges. So when you learned how to make your ionic compounds, right, we crisscrossed those charges to say, I can never do the other side. I got to work on that. Practice makes perfect, right? So we got 1 and 1. So general consensus for this would be the formula of X, Y. There was no +2 or -2 charge to give off that we would have a 2 here in the formula. So this one is out. Now it just comes to knowing your properties of your ionic compound, specifically with an alkali metal. Now, the biggest example that I can give is my favorite ionic compound of them all, NaCl, right? NaCl is table salt. You could always think of, this example for an alkali metal. Sodium is in group 1, and chlorine is one of your halogens. We all got salt as a condiment. Salt is my favorite condiment in the whole entire world, no matter what anyone says. What is your favorite condiment? Let me know. Is salt even classified as a condiment? I guess it's a spice. Are they the same thing? I use them interchangeably, but you let me know. But for any time that I'm reaching for the salt, right? What state is the salt in? Yeah, it's totally a solid. And that's the general consensus for ionic compounds, or ones that have ionic bonds. They would be solid at room temperature. So it's not likely that this would be a gas. Gases go with covalent compounds. Covalent compounds usually are liquids or gases. So you could have a mixture of both. So you could have liquids or gases. But solids are your ionic ones. So this one's out, which basically means that this is the answer choice, and we could use our knowledge of salt with water, right? When you put salt in water, you get salt water. And when you put a little bit of salt in your water, right, even if, even with, I guess we'll just keep it with salt water, right? For boiling water when you're making pasta. Ooh, that sounds good. What's your favorite pasta dish? I would have to say mine is, I'm a big fan of the Roman pasta dishes. So cacio e pepe and carbonara would be the top two. If you haven't had either of them, I highly, highly recommend at least trying them once in your life. Cacio e pepe, carbonara, whether you're making spaghetti carbonara or linguine, it doesn't really matter. But so anyway, so when you're making the pasta, right, and you add the salt when the water boils, you don't see the salt anymore. It completely dissolved. That's another word for saying soluble. Soluble means that compound will dissolve and disperse and dissociate in the water. Totally, salt will dissolve in the water. And that's a property of ionic compounds, especially ones with group 1 metals. Yay! What'd you think? I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe. And do all the cool things. Thank you so much for being here, right? Thank you so much for learning with us. Check out our website, glazersguide.com. We got tons more questions just like this one with video solutions like this one. We also have the big overall topic questions that you can learn from. Get your favorite drink, get a snack, and we have fun. We hang out, we learn together. It's a win-win. So let's go. I hope you guys having a great day out there, and I'll talk to you soon, okay? All right, bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.